Hello. These notes are going to be on writing quadratic equations and functions. Writing quadratic equations and functions. Okay, what does that mean? Well, we're going to be writing equations that are second degree polynomials. So we create equations and also functions, so we'll have the terms f of x, or the notation f of x and g of x with that stuff. Let me write down the goals, or the goal for the first part. For the problems that we're going to be doing, we're going to be given roots. So given roots, normally we would have to solve for these, but they want us to go backwards. We're going to be given roots, and we're going to try to write an equation that corresponds to the given roots. So, given roots, we are going to write quadratic equations or functions. Quadratic equations or functions. So, if we are given roots, there's a formula that we can use to write these quadratic equations. So if we are given the roots, we can find an equation using this formula. And it'll be a times bracket x squared minus r1 plus r2. These will be the roots, the first root and the second root, times x plus r1 times r2 equals 0. And I'm going to highlight some of these things. So this will be a root that will be given. They'll give us R1 and R2. Those are our two roots that they'll give us. And I'm just going to highlight them because I'm going to refer to them later. And that's right, where R1 and R2 are the given roots. So let's read it all over. If we are given the roots, we can find an equation using this formula where R1 and R2 are the given roots. A will be a constant, x is our variable. Okay, I'm going to highlight this in green. You'll need to memorize this. Must memorize. Memorize it. So, the first example, we're going to be given roots, and we're going to find a quadratic equation. So, example. Find a quadratic equation. These are the directions. Find a quadratic equation with integral... Find a quadratic equation with integral coefficients having the given roots. Having the given roots. So first I want to talk about integral coefficients. Sounds weird, but all it means is the coefficients of our equation have to be integers. So you can say integer coefficients, but they choose to word it like this: integral coefficients. And the given roots are 5 halves and -3 halves. So this is what our problem would look like, and we have to come up with a quadratic equation. And that's easy because we have a formula to do that. So R1 in this case will be 5 over 2. R2 R2 will equal negative 3 halves. And we'll plug those in to the equation above, or the formula above, and we'll be able to figure out our equation. So, first let me write down the formula with our roots plugged in. So, we'll have a times x squared minus 5 over 2 plus negative 3 over 2, whoops, times x plus 5 over 2 times negative 3 over 2. I did it again. Equals 0. Now I'm going to simplify. And then I'll have a times x squared 5 over 2 plus a negative 3 over 2, same thing as subtraction. So I'll have 2 over 2 x, and then 5 times negative 3 is negative 15 over 4. 2 times 2 is 4. Equals 0. Haven't done anything with that 0. And this will simplify to a times x squared minus x. This becomes a 1. Becomes a 1. Minus 15 over 4 equals 0. So, what do I do? What about this a part? I don't know what a is. I don't know what a is. And I have a fraction here. I wanted integer coefficients or integral coefficients. This is a fraction. Well, a is being multiplied to every term in this equation. I can choose a. I'm finding an equation. It doesn't have to be one specific equation. So I can choose a to be whatever I want. And if I want to have integral coefficients, I can choose a such that it will get rid of any fractions in my equation. And in this case, an a that will get rid of my fraction will be 4, because I'll have to multiply it through. So if I choose a to be 4, choose a equal to 4. And you will always be able to choose a in these types of problems. That's something that you're supposed to do. You're not supposed to find it in this case. So choose a to be 4, then we'll plug in our a, which is 4 times x squared minus x minus 15 over 4 equals 0. If I multiply it through, that will give me 4x squared minus 4x minus 15 equals 0, because the 4's will cancel out. And I have a quadratic equation with integral coefficients, so I'm done. This is my answer. Yeah. So let's write down the steps. First, we took R1 and R2 and we plugged them in. So first, plug in R1 and R2. So we're plugging it into this formula. Next step, choose a so that it gets rid of the denominators. That's what we did here. Choose a so that it gets rid of the denominator. So choose your a. Choose your a. And that's all there is to that example. So moving on to the next one. Let's make these blue, so it looks pretty. Same instructions, given different roots. So given these roots, 1 plus the square root of 2 all over 3. This is one root. And 1 minus square root of 2 all over 3. That's the second root. So with the same instructions, find a quadratic equation with integral coefficients. given these roots. So my first root, R1, is 1 plus root 2 over 3. And my second root, R2, 1 minus root 2 over 3. So, step 1, plug in R1 and R2 into our formula. So I'll have a times x squared minus first root, R1, which is 1 plus root 2 over 3. And I'm adding it to the second root, 1 minus root 2 over 3 times x, plus the multiplication of the two roots together. So 1 plus root 2 over 3 times 1 minus root 2 over 3. And that is equal to 0 by our formula. So I'll simplify this. A times x squared minus, I'm going to put these, since they have the same denominators, I'm going to put them above one denominator. So I'll have 1 plus root 2 plus 1 minus root 2 all over 3. That's times x. And then plus, just multiplying these together. 1 plus root 2 times 1 minus root 2 all over 9 in this case, since we're multiplying. Alright, let's simplify this. In this parentheses, this positive root 2 and a negative root 2 cancel out, so I don't have to deal with them anymore. So on the next line, I will have 1 plus 1 is 2 thirds. These cancel out. The 3 came from the denominator up here. Times x plus 1 times 1 is 1. 1 times 2, I'm just going to multiply this through. 1 times negative root 2 is negative root 2 plus root 2 and then minus 2. Square root of 2 times square root of 2 is just 2 all over 9 equals 0. And so one more step, or almost one more step. Again here, the roots cancel. Root 2's cancel out. So I'm left with a negative 1/9. 1 minus 2 is negative 1, and then over 9, which equals 0 from our formula. Now we have to choose A. That's the second step. Choose A. That gets rid of the denominators. In this case, I have two denominators. The A value that will get rid of both of them is 9. So choose A to be 9. I'm going to say that right here. Choose A equal to 9. So I'll have 9 times x squared minus 2 thirds x plus a negative 1/9 equals 0. And this will give me 9x squared. 9 divided by 3 is 3. So 3 times 2 is negative 6x, or 3 times negative 2. So I have negative 6x. And then minus 1 equals 0. And that's it. We have an equation with integral coefficients.